Hello. Today we're going to talk about solving two-step and multi-step equations. Uh, why would anything be called a two-step equation? That's correct, because it takes two steps, one, two, to solve. Multi-step, it's kind of like that binomial, trinomial. We don't say quadrinomial, we say just polynomial. Multi-step would be anything that has, I would say, more than two steps. Okay, usually has some simplifying to do before you solve. Okay, most of the equations that we solve, we'll solve in two steps once we've simplified all the way. So again, inverse operations, we're going to use the inverse property. Inverse property, we're going to add or subtract to create a zero. And we create that zero, right, because that's the identity property for addition. Inverse property for times or divide, we're going to multiply or divide in order to create a 1. All right, 1x, so that by the identity property of multiplication, all right, that 0 for adding or subtracting, or that 1 for multiplying, gives us the variable by itself or isolated, which is again what we want to do. So these two properties in combination, the inverse property and the identity property, are going to make up the reason that we go ahead and solve algebraically the way we do. And again, every time we solve a step, here's me. This is you can look and see that's Mr. Bossert there, all right, and whatever that guy's name is, Olaf or whatever. Okay, so if you can imagine us, where do we start on our steps here, our order of operations? Do we have to simplify? Do we have to do anything in parentheses or exponents or multiplication or division? That's usually distributive property. Adding or subtracting like terms. Or are we all the way down at the bottom and we're ready to solve by inverse operations to get back up the stairs? Okay, so it's kind of this circular motion. All right, woo, down the mountain, back up the mountain. Okay, where's the Snow Queen? I don't know. So where are we on the steps to start? Is there any simplifying to do? If there's not, then we're down here and we're solving by undoing additions and subtractions with the inverse properties, or undoing multiplication and division by the inverse property. And that gets our variable by itself. Do we have to undo any exponents or undo any parentheses? Okay. So I want you to imagine me and Olaf trying to figure out, or is he Sven? Which guy's Sven and which guy's Olaf? I don't know. One guy's a reindeer and one guy's a snowman with a big nose. Alright, so we're looking here. Do we need an additive inverse? Obviously for this one, we have x plus 14, so we need an additive inverse of, let's see if I can do this without messing it up here today, minus 14, or no, I can't, or adding negative 14. Come on, pen. And what I do to one side, I do to the other, and obviously that gives me x is 16. For this one, I need an additive inverse of positive 32 because that's going to create the 0. It's already negative, right? So I'm going to do plus 32. That gives me 0 minus x. Sorry about that. Which is, come on. Alright, which is 0 minus x we know is negative x. Alright, and if negative x equals negative 10, the property of opposites, I hate this guy, okay. The property of opposites says that if negative x is equals negative 10, then x equals positive 10. Or you could divide by negative 1, if that's what you choose to do. Or do you need a multiplicative inverse? Anytime I'm multiplying a fraction times a variable, or I'm divided here, I'm going to need multiplicative inverses to solve. Alright, the multiplicative inverse of 24/5 is 5/24. So just go ahead and multiply by the inverse. Alright, we know that if we multiply both sides by 5/24, alright, these will cancel over here and give us a 1x, right? which is x. That's isolating the variable. And then whatever this mess is over here. It looks like I would cancel the 20 and the 5. So I got 17 over 4 times 24 is 96 or something like that. 1796. Oh no, it's a really horrible fraction. Too bad, deal with it. Okay, and then example 4, it was divided by 8, so the multiplicative inverse is to multiply by 8 over 1. So if we multiply by 8 over 1 to both sides, this looks like fun. Can I do that? I cannot. Come back over here. Oh. Awesome. Okay. Again, the pen does not like me. I apologize. So this leaves me with negative x over here, and this is whatever this is, 240, 256. So negative x equals 256. Property of opposite says that x equals the opposite of that, negative 256. Right? What's the inverse of an exponent? Well, the inverse of x squared would be the square root. Okay? So to do the inverse of this, I'm going to square root both sides. Now, this is the point of the program where I say, who knows the answer to this? We've got some hands that go up in the air. I know the answer. I know the answer. And almost everybody gets this wrong the first time. I would say everybody, right? Write down your answer right now. Well, now you know it's a trick, obviously, because, well, otherwise, I mean, obviously the answer is 10. But it's really not, because it's the square root of x squared is, by definition, the absolute value of x. Right? Because x can equal 10 or negative 10 here. Both answers are correct. So x, because 10 squared obviously is 100, if you go back to the original problem. If we get rid of these things. 10, if we put in 10, 10 squared is 100. But negative 10 squared, right, remember we're going to substitute in with parentheses. Negative 10 squared is also 100. So both of those work. So you can't just say 10. If you said 10, which almost everybody did, you got half of the answer. When you're square rooting an x squared, you need to be looking for two possible answers. And in this case, both positive and negative 10. Positive 10 and negative 10 work. A lot of times we shortcut this, mathematicians shortcut this, and we'll say x equals, and we'll just say plus or minus 10. All right, and then this is getting both of the answers at once. What's the inverse of parentheses? Well, it's kind of ungrouping, right? We don't want to say parentheses of, what's the inverse of grouping? Or, right? Well, that's ungrouping. So we're going to take the 3 plus x divided by 7. Normally, you undo addition and subtraction first, but that 3 plus x is being grouped together. So we need to undo, first we need to undo by multiplying by 7. No, I give up. I give up. I hate that thing. Okay. So multiply both sides by 7. And that will cancel these 7s and give me 3 plus x. So I've ungrouped the 3 plus x. And 15 times 7 is whatever that is. 105 minus 3, x is 102. Please let my thing work. Great. Alright, stay there. Good. If you wanted to undo an x to the third or undo cubed, or something called a cube root, which basically means what thing to the third power equals 8. Obviously we know that that is 2. We'll get to that later. Okay, so a multi-step equation has simplifying and it could have variables on both sides. We know if we look at this equation over here, there's one step. This is a one-step solve. There's no simplifying to do here, okay, because for this, when I say simplifying, I'm talking about either side of the equation. So on this side, we got 4x, 4 times x. Can I simplify that anymore? Well, you really can't, because when you do 4 times x, you get 4x. I can't simplify 25. 25 is 25. So I'm basically here, and I need to undo. I need to start solving. And if you think of me and Olaf here, me and Olaf would be right here. We're going to need to undo the addition and subtraction on the way up. So I'm going to undo the times 4 by dividing by 4 to both sides, and we get whatever we get. 6 1/4. I just need to write slowly. No, that doesn't help. It doesn't help, does it? Who knows where my cursor is? Oh, there it is. Hello. Okay, 6 1/4. So, thinking about this one, where am I? Well, there is simplifying to do, because I can do, it's 5x minus 12 plus 3x, but on this left side of the equal sign, okay, if I split the equal sign into two things, on the left side, I can simplify that expression. That expression is really equal to 8x minus 12. And then go ahead and solve that. Add 12 to both sides, undo the addition. So again, I simplified it, and now I can't do anything with this. So now I'm down here, and I'm ready to go up the stairs. So I'm going to do the inverse of minus 12, which is plus 12. And this gives me 8x plus 0, which by the identity is 8x. 48 over here. And we know we divide by 8 to get x equals 6. Again, simplify first. We can simplify the left side of the equal sign by combining the minus 17x and the minus 8x to be minus 25x. Alright, so you can have 20 minus 25x, or you could have had negative 25x plus 20. And you go ahead and solve that. Inverse operations. The inverse of plus 20 is a minus 20, or negative 20. So we'll add negative 20 to both sides here. Come on. There you go, negative 20. Get over there. You can do it. Going to give me a minus 25x here. Alright, and come on, man. Help me out, would you? Alright. Over here, negative 125. And then, that's cute. Well, I gotta say, this is fun for you. Divided by negative 25, we're gonna get x equals 5. And here, simplifying to do. Well, there's distributive property to do here. So I can distribute this in here. I can distribute the negative 4. Make sure that you distribute a negative 4 in there. Make sure you distribute negative 4 into the second parentheses. So when I rewrite that, simplifying it, I have negative 3x. Negative 3 times negative 8 is a positive 24. Alright, and then negative 4 distributed into here. Negative 4 times 2x is negative 8x. Negative 4 times a positive 5 is a negative 20. Or minus 20. It's really getting super cool. Alright, and then I still have simplifying to do here on the left side. Alright, I can simplify this equation, this expression, negative 11x. And the plus 24 and the minus 20 is positive 4. And now you've got, if you recognize this, if I gave this to you at the beginning, you'd say, oh, that's a simple two-step equation. Subtract 4 to both sides, divide by negative 11, and we end up with negative 34 over negative 11, 34 elevenths, which should be 3 and 1/11th. So I take 3 and 1/11th. I would take 3.09 repeating. I would also take 34 of 11. That would be an okay answer too. I want you to go ahead and try this one on your own, and then I'll come back and reveal the answer. So pause it right now.